This call is now being recorded.
Okay, so now let us execute the third program. The procedure is first we have to create TCL file, then we have to execute it, and you have to also create arc file, then we have to execute the arc file. And here in this program, we are also going to plot the graph. So first let us execute the TCL file. Let us create the TCL file first. Gedit space name of the TCL file lab3.tcl. Let us type our program here. Okay, I'm just copying the contents of this program and I'll paste it. Okay, so now the content we have copied, save this. Okay, then close the window. Let us run the program. To run the program, the command is ns space name of the program. It is lab3.tcl. Okay, so we created the TCL file using gedit lab3.tcl. Now we are executing that TCL file by using the command ns space lab3.tcl. Press enter. So this will generate this animation file. Minimize this window and maximize this. So here is the topology. If you want to change the layout, you can click on this button, relayout, so that it will recreate the topology again. Okay. Yeah. So here, as you can see here, we have total 6 nodes are there. And let us run the simulation. We have 6 nodes here, and 2 nodes are source sending nodes, and 2 nodes are destination. Okay. So node 0 and node 2 are source nodes, and node 3 and node 5. So they are denoted by this blue color. And source nodes, we are indicating that by pink color, magenta color. And you can also observe here this line here, a horizontal line. This indicates it is the LAN. Okay. To this LAN, we have directly connected 5 nodes. That is node 0, 1, 2, 3, 4. These are directly connected to the LAN. That means these nodes are part of the LAN. But what about node 5? This node 5 is outside the LAN. Okay. It is external node. And what we are trying to do is one of our destination, that is node 3, is part of the network, internal node, whereas node 5 is external node. It is outside our LAN. And we are trying to send data to both internal node and external node. And we are trying to compare the throughput, like which node is going to receive more data in unit time. That is what we are trying to do. Obviously, the external node will experience more delay compared to internal node, right? Because the destination node 3, it is part of the LAN, so that the delay will be less. But for external node, it will experience more delay. Since there is more delay, the number of packets received will also be less compared to internal node. So just wait for the simulation to complete. Then afterwards, let us observe the throughput. Yeah. And you can see here the data is sent from node 0 and node 2. Okay, when these two nodes, when they forward the data, and you can see here it is showing that even node 1 and 4, they are also receiving the data. Because in LAN, what happens is that when a node sends data, it will be broadcasted, so that each and every node in the LAN will receive that data. They receive the data, they will check the address. If the address is intended to a particular node, then only they will open that message. Otherwise, the nodes will just ignore the message. Because of that, even node 1, which is not part of this communication, is also receiving message here. But it won't process the message because the destination address is different. The destination address is either 3 or 5. So node 1 will not open those messages, but it will receive the message since it is part of the network. Okay, so simulation is complete. Let us close this window. Now what is the next step? Now we have to create arc file. Okay. And before that, let us open our trace file. So what is the name of the trace file? It is, and before that, in this program, in the third program, you can see one trace file we are creating here. That is lab3.tr. Okay. This I'm trying to open now. Gedit space lab3.tr. Press enter. So this has opened our regular file. Okay, the trace file. And then we are also creating two more trace files. They are file1.tr and file2.tr. If you scroll down further, basically in this third program, what we are trying to do is we are trying to create congestion, and we are trying to um, showcase the TCP congestion window. Okay, so TCP congestion window, as we all know, is used to moderate the data rate. Okay, that is, since TCP is a reliable protocol, and it makes sure that the data is not lost when we are sending it to the destination. So what it does is that it will check the amount of data which we are sending. If there is, and for each packet sent, there will be acknowledgement. If we receive the acknowledgement, it means that everything is working properly in the network. If there is a missing acknowledgement, it means that the data is lost, probably due to traffic. So if there is traffic means we have to reduce the data rate, so that automatically suddenly the TCP will reduce the data rate. We'll check that. And you can see here in this file, we are creating, we have two source node, right? Node 0 and node 1. For each of the node, we are creating a trace file, file1.tr, file2.tr. Let us open these two files and see what is there inside. Gedit file1.tr. Yeah. And you can see here it has got these columns, and the last two columns you observe, the first one is the time. Okay. CWND underscore. It means it identifying this packet type, that is TCP congestion window. CWND means congestion window. And the last column, first value is 1.0. That means initially the TCP sent only one packet and it was waiting for acknowledgement. It received acknowledgement, so it increased the packet rate. Next, it is sending two packets. Again, it is receiving acknowledgement. If there is acknowledgement, it means the network is working fine. So it will keep on increasing the number of packets sent. And you can see here, it is increasing 20, 21, 22, 23, like that. So the network is fine, it is receiving the proper acknowledgement. When it reached this point, 26.538, at this point, it did not receive acknowledgement for this particular packet. So if there is no acknowledgement, it means there is congestion in the network. And how to resolve the situation? Reduce the data rate. So from 26, suddenly it will drop the data rate to 1. Again, it will start from 1. Send one packet, wait for acknowledgement. Like this, it will repeat. If it is receiving acknowledgement, it will keep on incrementing. Okay. Then once again, if there is missing acknowledgement, see at last it has dropped it back to 1 because of missing acknowledgement. This is called TCP congestion window. Similarly, file2.tr also we can open and see. File2.tr, it is for another destination. Okay, that is node 3. Yeah. So this also contains the same. So compared to that previous one, it is having higher data rate, 29, 30, 31, 32, because it is internal node. Internal node means the chances of packet being lost is very less for the internal node. But for the external node, the chances of packets getting lost is more. That's why the packet rate is also high for the internal node and low for the external node. Now considering these two files, file1.tr and file2.tr. So lab3.tr, that was the general trace file we generated. Afterwards, we generated TCP congestion window trace file, file1.tr and file2.tr. So now for these two, we are trying to plot the graph. Okay. we are extracting only column 1 and the last column, first and last column. The first column is the time and last column is the number of packets sent. So this we are going to plot. So out of these many columns, 7 columns, we have to extract only 2. How to extract? Again we have to use awk file. So let us write our awk file. Gedit space lab3.awk. In this, we have to write the content for our awk file. See, in this awk file, we are just checking the 6th column. If it is written cwnd underscore, it means that particular packet is the congestion window. So we are extracting column 1 and column 7. Column 1 is the time and column 7 is the packet number of packets. So I'll just copy and let us create our awk file. Paste it here. So now we created lab3.awk. Let us execute. Here the execution is little different compared to the previous 2 programs. How to execute is awk space -f space name of the awk file. Name of the awk file is lab3.tr, sorry, lab3.awk. So awk-f lab3.awk space, we have to give the trace file name. And here we are not giving lab3.tr. Instead of that, we have to give file1.tr and file2.tr we have to process. Because from these 2 files, file1 and file2, we have to extract the first column and the last column. So first, let us extract the first and last column from file1.tr. So I'm going to write now file1.tr. And after extracting these 2 columns, I'm sending that to another file called A1. Okay. So understand this line. AWK is the command to execute the awk file, followed by -f, then lab3.awk, that is name of our awk file, then trace file. We are not giving the general lab3.tr. Instead of that, we are giving the TCP congestion window trace file. The name is file1.tr for one of the source. This we are sending. We are using redirection operator, this greater than symbol. We are sending, extracting the first column and the last column, and we are sending that to A1 file. Press enter. If there is no error, you will get the prompt. Then next we have to do the same thing for file2.tr, because we are also calculating the throughput for another source destination pair. So lab awk-f lab3.awk space file2.tr. This we are going to send it to another file A2. Press enter. So now we sent the first and last columns to A1 and A2 file respectively. Next we have to plot the graph. For that the command is xgraph space A1 space A2. Okay, this A1 and A2 contains the 2 columns. Press enter. See, here it shows the graph, and you can see here 2 graphs here, 2 waveforms. One is in red color, another is in green color. Okay, A1 is for red and A2 is for green color. Okay, so the one in red color, that is having higher throughput compared to the one in green color is having higher throughput. See here around 32,000 compared to the one in red color, because external node will receive less data compared to internal node. And if you want, you can also just open A1 and A2 and you can check the contents of A1 and A2. What is there in that? Like gedit space A1. Press enter. See, it contains these 2 columns. These 2 only we used to plot the graph. Okay. Even A2 also will contain the same. So this is about the 4th column. Only thing is you have to get this graph.